Today's video, we start on page 8 of our chapter 9 notes packet, finding sine, cosine, and tangent of an angle, theta. Looking at the second case, the first case was when the point lied on the unit circle. This case 2 is for any point P on the coordinate plane, but not on the unit circle. All right, so we're going to look at problems in which the given point is on the terminal side of an angle theta. And we're going to find the sine of the angle, the cosine, the tangent, and we're going to write down the quadrant that the terminal side of angle theta lies in. So when the point P is not on the unit circle, right? Again, when it's not on the unit circle, this is what we do. These are the steps we follow. We plot the point. Draw a segment connecting the origin to the point. This is the terminal side of our angle theta. Mark theta, and then draw a right triangle. Always use the x-axis for the base of your right triangle, never the y-axis. And then use Pythagorean theorem to find the hypotenuse, also known as r, or the distance from the origin to the point. Then use SOHCAHTOA. Right? Or you can memorize this, that sine theta equals y over r, cosine x over r, and r is equal to square root of x squared plus y squared. I don't use this. I follow the 4 steps. Right? So for number 1, point P is negative 5, 12. So negative 5, 12, we'll plot that point. Negative, and we're just estimating here. This is about negative 5 and 12. All right, so here's point P, negative 5, 12. Well, first off, what quadrant are we in? Well, we're in quadrant 2. So we can answer part D, quadrant 2. Okay, so we plot the point. Then we draw a segment connecting the origin to the point. All right. Mark this theta. Now theta, this is going to be with the negative portion of our x-axis. Now draw a right triangle. Always go to the x-axis. So from the point, I'll drop a perpendicular down. And here I have right triangle formed. Now, from the origin to this point here, what is the length? Well, it was an x value of negative 5, so it's a length of 5. All right, the distance from the origin to this point here on the x-axis is 5. All right, but I don't want to forget about the negative, so I'm going to write negative 5. And from this point on the x-axis to our point P, what is this distance? What is this vertical distance? Well, it was our y value, which was 12. So this would be a height of 12. All right. Now we have the 2 legs of our right triangle, so now we use Pythagorean theorem. A squared plus b squared equals c squared. Okay. So 5 squared plus 12 squared, maybe some of you know this as the triple. 5, 12 what? 5, 12, 13 equals c squared. 25 plus 144 is 169, so c squared is equal to 169, so c is equal to 13. In other words, the hypotenuse of our right triangle here is 13, or our r value is 13. All right, so now to find the sine of theta, okay, we're just going back to our SOHCAHTOA, right? We're going back to using SOHCAHTOA. In relation to our angle theta, 12 is the side opposite, and negative 5 is the side adjacent, and 13, of course, is our hypotenuse. So the sine of theta is equal to opposite over hypotenuse, which would be 12/13. The cosine of theta is adjacent over hypotenuse, which is negative 5/13. And the tangent is opposite over adjacent, which is 12 over negative 5. And let's just look at our values, right? We are in quadrant 2. We're in quadrant 2. Our point is in quadrant 2, where sine is positive, right? Positive 12/13. Cosine is negative 5/13. And tangent is also negative 12/5. Next, number 2, we're doing the other 3 the same way. So we plot the point. So point P is 2, negative 2. So positive 2, negative 2. Oh, about here. We connect from the origin to point P. And then from point P, we want a perpendicular to the x-axis. There's our right triangle. Here's theta. Right. Now, the lengths here. From the origin to this point here, that's an x value, that's 2. And from our point P to the point on the x-axis here, this length, this vertical distance, is also 2. Again, so that I don't forget about my sign here being negative, I'm going to write negative 2. And this is our radius or hypotenuse of our right triangle. I'll just put a small h there. In relation to theta, opposite is the negative 2, and the adjacent is the positive 2. Now it's just SOHCAHTOA. Oh, nope, forgot. I need to find the hypotenuse, right? So 2 squared plus negative 2 squared equals c squared. 4 plus 4 is 8, and the square root of 8 will simplify to 2 square root of 2. So 2 square root of 2 is our hypotenuse. Sine of theta, opposite over hypotenuse. Negative 2 over 2 square root of 2. If we rationalize, multiply by square root of 2 over square root of 2, we get negative 2 square root of 2 over, oh, I should have reduced those first. That's all right, over 4. Because 2 times the 2 is 4. You know what? I'm just going to write it 2 times 2 and now reduce. So it looks like we end up with negative square root of 2 over 2. Cosine of theta is adjacent over hypotenuse. Adjacent is positive 2 over hypotenuse 2 square root of 2. And this would just simply be positive square root of 2 over 2. And the tangent of theta, opposite over adjacent, negative 2 over 2, which is equivalent to negative 1. And this point was in quadrant 4. Where tangent is negative, remember all students take chemistry, so in quadrant 4 only cosine is positive. And you can pause the video if you like and try the next 2 on your own. Number 3, we have point P has coordinates 1, negative 7. So let's just draw an x and y coordinate plane here. Positive 1, negative 7 puts us in quadrant 4 again. Connect the origin to the point and then draw a perpendicular to the x-axis. Here's our right triangle. Label theta. The x length is 1, the y 7, but again I'll put the negative so I don't forget about it. And what's the hypotenuse? Pythagorean theorem, 1 squared plus negative 7 squared equals c squared. That's 49 plus 1 is 50. The square root of 50 simplifies to 25 times 2. That's 5 square root of 2. So our hypotenuse is 5 square root of 2. Hypotenuse is a directed distance. It's never negative. All right. Okay. In relation to theta, the negative 7 is opposite, and 1 is the adjacent leg. So the sine of theta is going to be opposite over hypotenuse. So negative 7 over 5 square root of 2. And rationalize the denominator. We get negative 7 square root of 2 over 5 times 2 is 10. Cosine of theta is adjacent over hypotenuse, 1 over 5 square root of 2. Again, rationalizing the denominator will yield square root of 2 over 10. And the tangent of theta is opposite over adjacent, negative 7 over 1, which is simply negative 7. And we said before that we are in quadrant 4. And number 4, point P is negative 4, negative 2. Negative 4, negative 2. That puts us in quadrant 3. Negative 4, negative 2. I want to make my triangle a little larger, so try this. Here's point P. Negative 4, negative 2. Origin to the point. Point perpendicular to the x-axis. Never the y, always go to the x. Theta. Our lengths here. This horizontal distance is the x value, distance of 4, but again I'll write negative 4 because I don't want to forget about my sign. And then the vertical distance is 2. Again I'll write negative 2. Pythagorean theorem. Let's see, negative 4 is 16 plus 4 is 20. And the square root of 20 simplifies to 4 times 5, so it was 2 square root of 5. So our hypotenuse is 2 square root of 5. In relation to theta, the negative 4 is the side adjacent, and negative 2 is opposite. Sine of theta is opposite over hypotenuse. Negative 2 over 2 square root of 5. Why does this look so familiar? 16, 4 is definitely 20. Oh, that's why the other one was 5 square root of 2. Okay. Transposing these. Let me reduce these first. So negative 1 over square root of 5, and then rationalizing when we multiply by square root of 5 over square root of 5, we end up with negative square root of 5 over 5. I didn't show that step because I was running out of room there. Next, cosine of theta. Cosine of theta is adjacent over hypotenuse. Adjacent is negative 4, and hypotenuse is 2 square root of 5. I'll reduce this to negative 2 over square root of 5. I didn't leave myself room here either. End result, negative 2 square root of 5 over 5. Both sine and cosine are negative values, as they should be when we're in quadrant 3. Only tangent is positive in quadrant 3. And tangent is opposite over adjacent. Finally, some nice easy numbers to work with. Negative 2 over negative 4, which is a nice positive 1/2. And we said we are in quadrant 3. This concludes tonight's video. Thank you very much.